everyone, welcome back to my channel. This is the last part of solving a paper 1 of A levels. Let's start with MCQ number 31. So it is considering only structural isomers. What is the number of alcohols of each type with the formula this? So let's write it first of all. So we say it's C 5, 1 2 3 4 and 5, and we have one OH. Let's say H, H, and H, and H, H. So this is a primary alcohol. So how many primary alcohols can be made? It's very simple. So just move it from position number 1 to this position number 2 to position number 3. So let's say we have 1, 2, and 3. So three primary ones. So we have made so far 3. uh, where where else can we shift it? We can also shift it to some other. For example, if we are making like C and C, and here it's OH, and here is H, so we have to make two other ones, C and CH1 2 3 4 5 CH3 CH, and this one is CH3. So we can also shift it to another one, like here we can shift it to here, and there is formation of another primary alcohol. Like if we shift it to here, it is also a primary alcohol. So there can be 4, because if we shift it over here it would be same, it won't be different. So total number of primary alcohols are 4, so it can be B or C. Let's see how many secondary alcohols can be made. So if we for example, if we are moving this towards this carbon, like for this carbon, and we shift it more, so there can be 3 more secondary alcohol. How many tertiary can be there? Let's make it. So we have 1 carbon, 2 carbon, 3 carbon, and 4 carbon, and then we have 5th carbon here. So this can be, there can be 1 this tertiary alcohol. So the answer is, so which structure represent part of the polymer chain of PVC? So it's a polyvinyl chloride. So how is vinyl chloride? How do we write vinyl chloride? Vinyl is a word we use for basically 2 carbons. So vinyl chloride would have 2 carbons with a double bond. It is ethene chloride. So it's Cl H and H and H. And when we make polymer, the single bond is actually this pi bond is actually moving over here and here. So there would be formation of a polymer. So it would be, let's see, it would be B. So let's start with the next one, 32. Which structure represent part of polymer of chain of PVC? What is PVC? PVC is polyvinyl chloride. Vinyl is the word we use for ethene, means as a double bond, and chloride ions is chloride ion is present. So it would be C and Cl and H and H and H. Now this double bond or pi bond, the electrons would be shared over here and here to convert it into a polymer. So what can be the correct representation? So okay, look at the first one. Okay, this molecule is repetitive one, so this can be. In this B1 there are 2 chloride present on the adjacent carbon, so this one is incorrect, this one is also incorrect, and here there are the on the like alternative or the adjacent one is missing, so we are not going to choose this one as well. So A is the only correct option. Next one is 3. A possible mechanism for the exothermic hydrolysis of 2-chloro-2-methylpropane is shown. So first of all, this chloride ion is removed, and then because it becomes a carbocation, so a hydroxide ion is going to attach over here and makes it an alcohol. So, what is the correct representation? Let's see how much energy is released. So, this is not about the rate of reaction, though they have mentioned slow and fast just to confuse you, but it's not about slow and fast. It's about like the energy values that is required. So, we believe that the chloride ion has more energy value than the hydroxide one. So A is not the answer because it has one peak. D is not the answer because it has two peaks. So let's see whether C or B. So B is the most appropriate one because Cl has more value as compared to the OH hydroxide one. 34 compound W contains atom of carbon, nitrogen and hydrogen. Okay, it's a hydrocarbon with it can be, I mean it can be nitrile already given. So compound W reacts with HCl to produce propanoic acid. So amines are not going to react to make propanoic acid. Nitriles are going to react with okay. Then we have nitrile here and nitrile here. So it's propanoic acid. So definitely ethane nitrile is not going to react. The propane nitrile is going to react. So D is the answer. Let's move to the next question. 35. Two reactions are described. First is 2 bromo 2 methyl butane and then 2 chloro 2 methyl butane. And in both reactions the conditions are same, and we they have given us condition they have given us something for 2 bromo 2 methyl butane forms this product. Okay, so which row is correct? Let's see. First of all, they have given us the percentage yield. For this one we need theoretical yield, and actual yield is already given. Actual yield is 12, sorry, is 12.32 grams. Okay, so we have to calculate the theoretical yield. So we'll do it later. Let's discuss the next part. Which reaction is faster? Okay, so we have chlorine and we have bromine. So we say as we move down the group in halogens that electronegativity decreases, due to which the bromine basically leaves the atom easily and the reaction rate is faster. So we say one is faster than two. So let's see what is the actually, oh sorry, the percentage yield. So let's calculate the theoretical yield. We have an equation. Let's say we have C, we have a butane, and then we have 2 bromo and 2 methyl. So this is the molecule that we have. So it reacts with sodium hydroxide. So when it reacts with sodium hydroxide, the sodium reacts with bromine and this bromine is replaced by NOH. So sorry, the hydroxide. So the equation become H3C, C and CH3, and we have CH2. Here we have OH now, and here we have CH3. So this is your product. Let's calculate what is present in product. So what is the mass of product or what is the mass of reaction? So this is the general equation that we are going to discuss. So number one, this one, the mass given is 30.18. Let's calculate the moles of this. Moles of reactant. 30.18 divided by is given 150.9, and the moles are 0.2 moles. So let's calculate the mole of the product now. So the mass would be 1, 2, 3, 4, 5, 6, 12, oh, sorry, 5 into 12 is 60, and then we have 16, and then we have 12 hydrogen. So this becomes almost 88. So moles of product would be 88. Okay, so what is the mass of this one? So moles are similar. If it has 1 mole, this would also have 1 mole. So the moles are same, and the sorry, moles are 0.2 and molar mass is this. Okay, how do we calculate? We would calculate it by taking a simple molar ratio. So if you look at this, this is 1 mole and this is 1 mole. So molar ratio is 1:1. If it has zero point 0.2 moles, the product also would have zero point 0.2 moles. So let's calculate the mass of product. So 0.2 into 88, that would be 17.6 grams. So this is theoretical yield. Let's calculate it again. So the formula is percentage yield is equal to actual yield divided by theoretical yield. I'm not writing you yield, but you need to write multiply by 100, and the answer, the actual yield is 12.23, oh sorry, 32, divided by we have what we have calculated, 17.6, multiply by 100, so the answer is 70%. So C is your correct answer. Next, 36, an alkane P reacts with an excess of acidified potassium manganate. Methyl propanoic acid is the only product. So what is alkane P? So as you can see, we have a propanoic acid with some methyl group, and okay, we have, this is the only product that we have. So we are converting an alkene into carboxylic acid. So we can apply it to, we can apply it to either the 6 carbon one, which is this first one, or the C1. So these are the two only possibilities that we have. So let's see which is the correct possibility. So we have methyl propene. So if it cannot be directly converted into this one, while if we talk about this one where we have two methyl, one here, okay, 1 2 3 4 5 and 6, and we have at third position we have a double bond, and we have a methyl group here, and we have a methyl group here. So we need to cut this double bond because here we need to convert it into a carboxylic acid. So this can be the answer, that this can form methyl propanoic acid in an more appropriate way than the C1. So three substances are listed: butane, hydrogen, and hydrogen bromide. Okay, it's a free radical substitution reaction. Let's figure out how can we write it. So when we talk about the free radical substitution reaction, we have to follow a certain pathway, because first of all there is an initiation, then there is propagation, and then there is termination. So they have already given us, it's a bromine, so I'm not going to write the initiation. We have bromine, the free radical, it is going to react with the ethane, that is C. Oh, okay, I'm writing like this: CH2 and CH2. So I'm writing for propagation only. So first of all it becomes sorry, ethane, my bad, it's a single bond, sorry. Okay, when it reacts with this one, so it will form CH2, let's say sorry, CH3 and CH2 with Br. Okay, and then there is release of HBr. Okay, let's write the substitution reaction for this one. So we have ethane, C₂H6, so we have CH3 and we have CH3. I'm not going to write the free radical initiation one. I'll start with the propagation. So it reacts with bromine free radical. One hydrogen is drawn from here. So it will become C₂H5, a free radical with HBr. So one of the product is this HBr. Let's see what is the second product. So this when this C₂H5 are like continued to be made, and what will happen in the termination, these C₂H5 react together to form C₄H10. So a butane is formed. So nowhere in this hydrogen is formed, only butane and hydrogen bromide is formed. So your answer is C. Next question says, sorry, the structure of testosterone is this one. Which statements are correct? Let's calculate. Carbon atom C1 and C2. So here we are starting C1, and here we have C2, let's say, can be oxidized with acidified K2Cr. Okay, both cannot be, one can be, so we are not going to choose this one. There are fewer than 27 hydrogen atoms in testosterone molecules that you need to calculate. So they're not less than 27, by the way. You need to calculate by yourself. There are 6 chiral carbons in each one testosterone. Let's see how many are they. So it's 1, and then it has 2, then 3, 4, and then 5, 6. So we have 6. So the only correct option is this D. The next one is the structural formula of there is sorry, triene is present, means 3 triple bonds are present in this one. So how many carbons would have sp2 hybridized? Like how many carbons are involved in double bond? In other words, so let's see. If there are 3 bonds, let's make this. So there can be 4 carbon is involved. So simple, the answer is A. There's no need to go into the details of this one. Last one is hydrocarbon X is saturated, and each molecule contains one ring of carbon atom. Okay, the max spectrum of hydrocarbon X is measured. The peaks representing is this, and the peak representing m plus 1 is this. Okay, let's calculate this. First of all, we need to calculate the abundance. Let's calculate abundance of m1 plus 1, sorry, peak is, let's say, 1.1. So how many carbons are there? We need to calculate that. Let's calculate it with the value of n. N is equal to, the abundance is 100 and it's 1.1, and then we have a height of peak which is 14 mm. Height of peak, I'm writing this in bracket, okay, it's 14, and then we have the height of peak, which is for m, sorry, for m plus 1. I've written wrong. It would be, sorry, it would be 0.77, and then we have to write the height of peak for m only, that is 14. So when we calculate this, the answer of n is 5. So there are 5 carbons in this one. It would be C₅H₁ because it's a saturated carbon. Let's calculate its mass to charge value. The mass to charge value will be calculated with the formula. What is the mass? The mass of this one turns out to be 70. So let's say this one is this, and the charge is 1. So answer is 70. So this is all for this paper. See you with next paper. If you want to know the answer of some question in detail, you can ask me in the comments, and see you in the next video. Goodbye.